Om Sri Sai Ram. Welcome to the second session of the chapter Force and Laws of Motion. We have just rewinded the last chapter motion and just started the force, definition of the force. Alright. So, in this chapter we will discuss about the beautiful laws of motion. So, how the motion is governed by some laws. Alright. To describe this, we need to go back in history where the scientists started imagining how these objects are moving. Okay, objects are moving. So, how these objects, what makes these objects move? So, this was the question. And why is it coming to rest? As you already know, our Aristotle, who is the father of biology, he has landed in so many fields of ethics, politics. So, he kind of deduced this motion as the natural state of an object is at rest, that all objects seek this state and constant outside action is required to keep an object in motion. So, he is saying that every object wants to be in a state of rest. Alright. If you have an object A, okay, it wants to be in the state of rest. That means he is telling every object in the universe, the natural state of it is rest. If you move it, it will move. As he said, external action need to be put on the body to make it move. After moving also, it comes to its natural state of rest. It stops at point B. So, why is it happening? So, he thought of this as every object needs, every object's natural state is rest, and he is telling if you move anything it comes to rest. So, this is what he argued. Now, his contemporary Galileo thought it is not the case, and to see what are the flaws on the Aristotle, the first flaw you can see is concept of rest, right. What is the concept of rest? You are moving, you may be traveling in train, right. When you sit and watch outside your window, maybe your friend is on the other train of other end of the track. Suppose one of the train is moving. It is general tendency that either of you or two of you will think that your train is moving, yes or no? So you do not know who is moving and who is at rest. If a man moving on bicycle, you can say that he is moving, right. You are standing still and you can see a man moving in bicycle and you can say he is moving. And the same version, the man who is on the bicycle will say the man who is on the ground is moving backwards to me. He is staying still and the man who is on the ground is backwards to me, he is going backwards to me as he is going forward. He is thinking that he is at rest. So, the concept of rest is flawed there. We do not know who is at rest, who is in motion. So, natural state of object coming to rest will not be identified when we do not know who is at rest, right. The other person will think that you will come to rest, you may think the other person will come to rest. So, natural state is flawed there. And the second and important thing is the motion of an object triggered in space. What do I mean by this? If you send an object in space, like a spacecraft which is not revolving around the earth, in space you push with the velocity where there is no atmosphere, nothing. What happens? It goes with the velocity, it does not stop, right. It does not stop. So, what happens then if the natural state of an object is at rest, then why does it come to rest? It keeps on moving. Aristotle has another definition that planets keep on moving around the earth because of an external force which he dedicated to Almighty God. So he is kind of moving around the planets, but any object that is moving in space, he has no answer for that. Now Galileo comes into picture. So Galileo comes and says that he observed something very insightful. What he observed? The natural state of an object was simply to keep whatever motion it had, and that force was needed to change the motion. The force that eventually brings most everyday objects to rest is friction. Friction, of course, right? So what he is trying to say is, every object wants to retain its state. For example, if an object is at rest, it wants to retain its position. That means it wants to remain at rest. If a body is in motion, if you give a velocity to a body, it wants to retain the velocity, it wants to remain to move in that velocity. If we want to slow down or stop that object or change the motion of that object, what we need to do? We need to apply external force on it. In simple words, he is saying is, if you give an object a velocity, it always retains its velocity. So for this, he has done a famous experiment. What he done? Let me draw and show you. He took a ball. This is the experiment setup. All right. So you have a ball here. This is at a height h. Okay. This is also at height h. So both these heights are equal. Now what he does is, he dropped the ball. As he dropped the ball, what happens? The ball will increase its velocity, right? It will catch up the velocity as it comes down. So it catches up the velocity, it comes here, and he observed, and you already know, it comes and goes to the same height. The energy lost, it will regain to the same energy. All right? Considering this is a frictionless force, frictionless surface, there is no friction acting on it. And you can see the ball may come here, or more or less it will come here, it may come here. And he also deduced that the change in height is because of friction offered by this surface. So in imaginary world, where this vessel has no friction, it will go and regain its height. All right. Now what he done is, he increased a bit more. Now this angle is same. Now what happened? He slightly decreased this angle. So this angle is somewhat, say, x. What happens? Now this angle is less than x. He decreased this angle. Now if he decreases angle, it needs to go far to attain this height, right? So here he decreased the angle. Here you can see, if it is, instead of x, here if it is 60 degrees, let us say it is 50 degrees. Okay. So here he kind of decreased the angle. If you decrease the angle, what happens? He raised the ball. He again threw a ball. It picked up the velocity. This is the height h. Again this is the same height h. So now previously this distance was equal to this distance, because this is also 60 degrees, this is also 60 degrees. Now when it gathered the velocity, it again want to attain the same height, right? So it traveled even more to get the same height. Here the distance is less. It travelled even more distance to attain the same height. So you can observe this is not depending on this distance. It want to always go to the same height. It is getting the velocity, it is picking up the velocity, and it always wants to attain the same height. Now the imagination goes from reality to practical, reality to hypothesis. What he does is, if the particle, if the body wants to attain the same height, when I decrease the angle, it doesn't bother about how much distance it wants to travel. It will travel as much as distance, it has to attain the same height. Now what he done? He has flattened the surface. Imagine he has flattened the surface. What will the body do now? It has no height to reach. It wants to reach that height. There is no external force to stop it here. Previously it comes down, it attains some velocity, it gains some velocity, it goes and uses all the velocity at the height it came from. It came from some height, it will go to that same height and loses all the velocity, because there is an opposing force, there is an inclined plane. Now there is no opposing force, it gained the velocity up to here and it want to go to the height. What happens here? There is nothing inclined here. It will keep on moving and moving and moving and moving infinitely to grab that height, if there is no friction here. So that says that if a body is given some velocity, it will keep on moving. It won't keep it won't change its motion until and unless an external force is acting on it. It wants to retain its position. If it stops, what he says is it is because of the friction which is opposing the motion. In everyday life, we walk and we do everything because of the friction, right? So he tells that if you give an object some velocity, it will always want to retain that velocity until an external force is acting on it. Rest is the special case of velocity where v is equal to 0, right? So what is inertia? If you have an object here, you want to move the object, right? You need some force to move the object. The object won't move very easily, right? That means it is offering some kind of resistance. I won't move, right? So this kind of resistance possessed by a body is called as inertia. If a body is moving also, it takes some effort to to make it stop. For example, you can see in India, you can see so many times that there are several people coming out of the running bus. When they get down from the running bus, what they do? They will walk a little bit, right? They can't stand still and go back to their desired place. Why they do so? Because as they are coming with the bus, they acquire the velocity of the bus. When they are dropping down, means their body resists to change the motion. They are moving with the velocity, all of a sudden he wants to get down. It doesn't happen all of a sudden, right? The body doesn't want to be at rest. It wants to continue to be in that motion. That kind of resistance offered by the body is called inertia. All right. So, for example, you can see when last year also when I asked my student why the body stays at rest, why the body in motion keeps in motion, doesn't want to be at rest. So many of the students answered because of inertia. Now I want to clarify this concept, like there is a difference between naming something and reasoning for something. All right. If you have already studied in class 8 physics, if I ask you why the light comes and goes, bounces back, you can say it is because of reflection. If I ask why the light ray bend in any medium, you can say it is because of refraction. Why any of our shoes get worn out, you can say because of friction. Actually, it is not because of friction. If you see a shoe is worn out, it is friction. If you say light is bouncing back, it is not because of reflection, it is reflection. If the light is bending, it is not because of refraction, it is refraction. In the same way, if the body is not stopping, if the body wants to stay at rest, it is called as inertia. The resistance is called as inertia. It is not because of inertia. We don't know why it wants to stay at rest. That we don't know, right? So, we can't say it is because of inertia. We name it as inertia. For example, we sent the spacecraft called Voyager in 1977. All right. So, it crossed Jupiter, it crossed solar system. So, it keeps on moving and moving and moving. So, it doesn't come. So, we can say that if you give some velocity, it will keep on moving. But can we be for sure say that it will not come to rest? We don't know. The answer is we don't know. If something moving for 100 years and may come to rest tomorrow, we don't know that. But seeing what are happening around us, the data around us, we may qualitatively conclude that yes, if you give an object a push, it want to retain its velocity, it want to go in the same type of motion, whether it is rest, it will be in the rest, whether it will be in the, if it is in the motion, it will be in the motion, unless and until somebody is hampering them. All right. This is the main difference you need to understand between the reasoning something and naming something. So, having known this, we need to learn a little bit more about inertia. So, on what the inertia is depending on, you can see a small guy, poor fellow, now he is safety measure, he won helmet. See, the elephant is there, he is going and playing with the elephant, he is trying it to move it, but unsuccessful, mission unsuccessful. What happened here? Well, you can also see the terms more inertia, less inertia. You can also intuitively say that a body will have more inertia when it has what? More mass. A body will have less inertia when it has less mass. It will have less resistance. It is easy to move a thin guy than a strong guy, right? In the same way, because the resistance of their movement will be more. So, here it is depicted in this example. So, now quantitatively inertia is measured by its mass. So, if you have more mass, you will have more inertia. If you have less mass, comparatively it will offer less inertia. Inertia means what? Resisting to move, right? Resisting to a change in state of motion. If it is at rest, it wants to stay at rest. If it is in motion, it wants to stay in motion, right? With this all groundwork, let's go and explore now the first law of what? Motion. What the first law of motion and who discovered it? And we gave this credentials to Newton, but the main part of it, Galileo did the main part of it, as Newton has the other two laws also. He also grabbed this first law. So, let us go and start with Newton's first law of motion. So, we give this credentials to the Newton because he has already two laws in his pocket. So, this law also he took it, but the main groundwork has done by Galileo. What this Newton's first law states, you can see Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Right? What it tries to say is the same thing which we had discussed here. What we had discussed? An object continue to be in its own state until and unless we compel a force on that object. For example, a body is moving with some velocity. It wants to move with some velocity, with the same velocity, until we kind of do something externally to that velocity, to that object. If we don't disturb that object, it will retain its velocity and it will keep on moving. All the things around us in the world tend to stop. Why it tend to stop? Because there is opposing force acting on it, that is called as force of friction. So a body is moving and the friction is acting opposite to the direction of motion. That's why it will keep on slow down and stops. So if there is no external force, for example, you don't have anything, you don't have any friction on the surface, so you will keep on moving if the body is in motion, right? So you can watch again, you can just read again the definition. Let's go and read once again. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. So much is confined in this little statement. If an object is in circular motion, this law does not validate, okay, because some force is acting on it to make it circular path. He is telling only the object that is moving in straight line, okay, uniform motion, that is in straight line, it will maintain the same motion until and unless it is experienced by or external force. And this is taken as the definition of inertia, right? Inertia means what? Resist to change of motion. It resists for any kind of change of its motion, whether it is rest or in motion. Rest is a special case of motion where the velocity is equal to 0. Hence, this first law we call as law of inertia. All right. So first law we call as law of inertia because it says that it says the same thing as we define the inertia. Inertia resists to change in motion. So nobody wants to change its motion, whether it is in rest or it is in motion. All right. Now the first law, we have already understood this first law. Everything is done. We have we have covered from the historic what are the views of the scientists and slowly developed the concept to reach the concept of inertia. Now if I tell you, you are watching this lecture, you sat down. After this lecture, you will go up and go and do your work, right? So does any external force is acting on you? External force means sometimes somebody needs to lift you up and take there, right? So does the Newton's law is invalid there? You can see some dogs sit. It stands up and goes somewhere. Who is making it stand? Does Newton's law is not valid for dogs? Who is lifting the dog? Who is making the dog move? You need to understand that. To give you this hint, for example, you went with your friends in a space. One of your friend is outside the space. You told your friend, it's time out, let us go back to Earth. You are not doing anything, you should come back, you should come yourself to the spaceship. He just got off the spaceship, you want him to come. Can he come back to the spaceship without using any kind of external force? Think about it. We'll discuss in the Newton's third law, right? So this is about the Newton's first law, which we defined as the law of inertia, right? Hope you enjoyed this session. Before going to next session, I want to give you some small questions which we have covered till now. Let us go and see. The first question is, which of the following has more inertia? A rubber ball and a stone of the same size, a bicycle and a train. We already discussed on what factors the inertia depends on, so you can easily answer this question. Second question, explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Why does the leaf fall off? You need to answer. It is very easy, right? Third one, a moving body can continue moving on a frictionless surface only when a force is acting on it. Does a moving body really want a force to move on frictionless surface? Write if it is true or false, and you need to justify your answer. Fourth question is, inertia is only valid for the objects at rest. True or false? Again, you need to justify your answer. With this, we will end this session. Hope you enjoyed it, and next session we will come and discuss more interesting concept, which is Newton's second law, which we talk more emphasizing on force. How does it work, right? Till then, thank you. Sai Ram.